Good morning, student. Today we are going to discuss about the new chapter, Group 18th Element, Chemistry Second Year English Medium, Part 1. Yesterday, discuss about the 7th year group elements. That is the last chapter. Remaining another one. Today discuss about the another group of the 18th elements or group 18th elements. It is also known as a noble gases or inert gases. Noble gases or inert gases. Here is the group elements. Group 18 elements are commonly referred as a noble gases. Here is the group 18 elements or 18th group elements are commonly referred as a noble gases or inert gases, which is include those elements are helium, neon, argon, krypton, xenon, radon. Those elements belongs to 18th elements are noble gases or inert gases. It is also called as the 18th group elements by the IUPAC notation. IUPAC notation. The group elements are commonly referred as a noble gases or inert gases, which include helium, neon, argon, krypton, xenon and radon. Those elements belongs to 18th group elements or 8th group elements or 0 group elements or 18th group elements by the IUPAC notation. Those elements also known as a noble gases or 0 group element or inert gases. The general electron configuration of the noble gases are NH2NP6. Here is the commonly electron configuration NH2NP6. The number of s orbitals are considered 2 electron and number of p orbitals consists the 6 electrons. 2 plus 6 is equal to 8 electron. The outermost cells are the full paired electrons. So it is also called as a noble gases, because of those outermost cell full filled with the electrons, or exists the octant rule, because of all outermost cell consists the full paired of electrons. So it is also called as the octant rule or stable electron configuration. Except helium, all elements are exist the NH2NP6 electron configuration. It is also called as a octant rule electron configuration. Octant rule electron configuration. Octants means that the 8 electrons consist the outermost cell. So it is also called as a octant rule. Next, another one, occurrence. Except radium, in 18th group elements, except radium, all noble gases are present. All noble gases are present at atmosphere 1% of the volume. Here is the occurrence of the 18th group elements or 0 group elements or noble gases. Here the except radon, all noble gases are present in the atmosphere. All noble gases are except radon. All noble gases are present in atmosphere by the 1% of the volume. By the 1% of volume. Next, another one, argon is the major constituent in the atmosphere. Here is the in 18th group elements or noble gases, argon is the major constituent. Argon is the major constituent in the atmosphere. Next, another one, mineral of radioactive origin contain helium and neon. Helium and neon. Here is the mineral. Which mineral? A radioactive mineral. Here is the radioactive origin contain helium and neon. Radioactive origin contain helium and neon. That is the mineral of radioactive. And next, another one, helium and radon. Helium and here is the xenon, Xe. Xenon and radon are the rarest elements of this group. In noble gases or 0 group elements, xenon and radon, two elements are the rarest elements. Rarest elements in this group are noble gases. Here is the in zero group elements are noble gases. Here is the radon and xenon. Two elements are the rarest elements in this group. In this group, that is the occurrence of the 18th group elements are noble gases. Here is the noble gases. Noble gases was first isolated by the Bartlett in Colombo University. That is it is isolated. The Bartlett scientists isolated the xenon compound. Xenon compound, that is also known as a xenon react with the fluorine and oxygen. That is also known as a xenon oxides. Next one, xenon fluorides. The first compound is the isolated by the Bartlett in Colombo University. That is the compound is the xenon hexafluoroplatinate. Xenon hexafluoroplatinate. That is the compound. It is compound is isolated by the Bartlett in Colombo University. That is the first scientist name is the Bartlett scientist. That is the discovered the xenon compounds. That is the xenon react with the oxygen and fluorine. That is also known as a xenon compounds. Xenon compounds. The outermost valence cell electron configuration NH2 NP6 except helium. Except helium. Here is the number of s orbital consists the 2 electron and number of p orbital consists the 6 electron. So here is the outermost cell consists the 8 electrons. So it is also called as a octant rule. Octant rule. Due to the presence of outermost cell consists the 8 electrons in the valence cell. So it is also called as a octant rule or stable electron configuration. Or stable electron configuration. Next another one, elements, symbol, atomic number. Next one, electron configuration. The first one, helium. Helium symbol is the He. Atomic number 2, electron configuration 1s2. Next another one, neon. Neon symbol is the Ne. Next one, argon symbol is the Ar. Krypton symbol is the Kr. Next one, xenon symbol is the Xe and radon symbol is the Rn. That is the elements of the zero group elements. Elements of the zero group elements. That is the symbol. Here is the helium atomic number 2. Helium atomic number 2. Here is the electron configuration is the 1s2. That is the outermost cell consists of 2 electrons. So it is also atomic number is the 2. Next one, neon atomic number 10. Here is the electron configuration 1s2, 2s2, 2p6. Here is the 2 plus 2, 4, 4 plus 6, 10. That is the outermost cell consists of the 8 electron. Outermost cell consists of the 8 electrons. So it is also called as the octant rule or stable electron configuration. Except helium, all noble gases are stable. Due to the presence of the outermost cell consists of the 8 electron. So it is also called as the octant rule. Those elements, electron configuration is the more stable remaining of all groups. Because of those outermost cell consist of the 8 electron or full-filled electrons. Full-filled electron. So it is also called as a stable electron configuration. Next another one, argon. Argon atomic symbol is the Ar. Atomic number 18. Electron configuration 1s2, 2s2, 2p6, 3s2, 3p6. 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12 plus 6, 18. That is the outermost cell consists of the 8 electrons. Next another one, krypton. Krypton symbol is the Kr. Atomic number 36, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. Here is the 2 plus 2, 4, 4 plus 6, 10, plus 2, 12, plus 6, 18, plus 10, 28, plus 2, 30, plus 6, 36. The outermost cell consists of only 8 electron, 4s2, 4p6. Next another one, xenon atomic number 54. Xenon atomic number 54. Here is the electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6. That is the outermost cell consists of the 5s2, 5p6. Next one, xenon atomic number 86. electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6, 4f14, 5d10, 6s2, 6p6. Here is the outermost cell consists of the 8 electron. Here is the all noble gases. Outermost cell consists of the 6s2, 6p6, 5s2, 5p6, 4s2, 4p6, 3s2, 3p6, 2s2, 2p6. So here is the outermost cell consists of the 8 electron. So it is also called as a stable electron configuration or octant role. That is the electron configuration of the 0 group elements or 18th group elements or noble gases or inert gases. That is the electron configuration of the 0 group elements. Next one, chemical properties of the 18th group elements or noble gases or inert gases. Here is the chemical properties. The first one, those gases are monoatomic nature. Here is the all 0 group elements. Here is the helium, neon, argon, krypton, xenon and radon. Those elements are monoatomic nature. Monoatomic nature and easily soluble in water. Easily soluble in water. That is the first physico-chemical property or chemical properties of the 18th group elements. All noble gases are monoatomic nature and easily soluble in water molecule or easily dissolved in water molecule. All noble gases or 18th group elements are the monoatomic nature. Mono means that the single or one, only one atom. That is also known as a monoatomic nature. Here is the helium, neon, argon, krypton, xenon and radon. Those elements all exist only one atom. That is also known as a monoatomic nature and easily soluble in water molecule. That is also known as a monoatomic nature and easily soluble in water molecule. That is the first property of the 18th group elements. Next, another one, the noble gases are colorless. Noble gases are colorless and odorless and tasteless gases. All noble gases are colorless gases. Does not exist the color. So here is the all noble gases are colorless and odorless and tasteless. Odorless and tasteless, which is very low melting points and boiling points. The all noble gases are exist the low melting points and boiling points and odorless, tasteless and colorless. That is the second property of the 18th group elements or noble gases. The boiling point of the helium. Here is the boiling point of helium is the lowest of any substance. In the all noble gases except helium, remaining all elements are exist the high boiling points. But here is the helium. The boiling point of helium is the lowest of any substance or remaining elements. That is the helium, argon, krypton, xenon and radon. That is the third property of the 0 group elements. They are least reactive. All noble gases are least reactive because of all noble gases. Here is the all noble gases are least reactive because of or due to the presence of the noble gases are except helium. That is also known as a 1s2. Having the completely filled with the NH2 NP6 electron configuration or octant electron configuration. Here is the all noble gases are least reactive or low reactive due to the presence of the all outermost cell or valence cell exist the 8 electron or filled with the electrons. That is also known as a least reactive. All noble gases are the least reactive because of all noble gases are except helium. Here is the helium atomic number 2 except helium 1s2, remaining all elements having the complete filled with the NH2 NP6 electron configuration or NH2 NP6 orbital in their valence cell. That is the chemical properties of the 0 group elements or 18th group elements. Remaining another one, xenon fluorine compounds. Xenon fluorine compound. Xenon react with the fluorine to form of the xenon compound. That is the preparation of the xenon fluorine. Xenon fluoride compound. That is the first one. Xenon react or combining or treated with the directly with the fluorine. Here is the xenon react or combining with the directly with the fluorine under experimental condition to form of 3 binary fluorides. 3 binary fluoride, that is also known as a xenon difluoride. Di is the 2. Xenon tetrafluoride, tetra means that the 4. Next third one, xenon hexafluoride, hexa means that the 6. That is the 3 binary compound of the xenon difluoride, xenon tetrafluoride and xenon hexafluoride. That is the 3 binary compound. Here is the preparation of the xenon fluorides. Here is the xenon react or combining with the fluorine, under experimental condition to form of 3 binary compounds like that xenon difluoride, xenon tetrafluoride, xenon hexafluorides. Here is the first one, xenon react or combining with the fluorine at 673 kelvins, 1 bar pressure to form of xenon difluoride. To form of xenon difluoride, di means that the 2 fluorine combining are treated with the xenon compound. That is also known as a first preparation of the xenon difluoride. Xenon react or combining with the fluorine to at 673 Kelvin and 1 bar pressure to form of a xenon difluoride. That is the preparation of the xenon difluoride. Next another one, xenon react or combining with the 2 moles of the fluorine. 2 moles of the fluorine at 1:5 ratio at the 873 kelvins, 1 bar pressure. 1 bar pressure to form of a xenon tetrafluoride. Xenon tetrafluoride. Tetra means that the 4 fluorine atom combining or react with the xenon to form of a xenon tetrafluoride. Here is the preparation of the xenon difluoride. That is the first one, xenon reactor combining with the 2 moles of the fluorine at 1:5 ratio at the 873 kelvins, 1 bar pressure to form of a xenon tetrafluoride. Xenon tetrafluoride. That is the preparation of the xenon tetrafluoride. Remaining last one, xenon reactor combining with the 3 moles of the fluorine at 573 kelvins and 60 to 70 bar pressure, then form of xenon hexafluoride. Hexa means that the 6 fluorine atom combining or react with the xenon at 573 Kelvin and 60 to 70 bar pressure, then form of xenon hexafluoride. Xenon hexafluoride. Next, that is the 3 binary compounds. 3 binary compound, xenon difluoride, xenon tetrafluoride, xenon hexafluoride. Next another one, xenon react or dissolved in the water molecule to form of a xenon oxy compounds. Xenon oxy compound. But here is the xenon tetrafluoride. Tetra means that the 4 atom. 4 fluorine atom react with the xenon to form of a xenon tetrafluoride. Xenon tetrafluoride react with the dioxy difluoride, O2F2. Dioxy difluoride to form of a, here is the 4 fluorine atom react with the another 2 fluorine atom. 4 plus 2, 6. That is also known as a xenon hexafluoride and another one O2 is the form. That is the preparation of the xenon fluoride compound. Xenon fluoride compounds. Here is the xenon react directly with the fluorine under experimental condition to form of a 3 binary compounds like that xenon difluoride, xenon tetrafluoride, xenon hexafluoride. That is the first one, xenon react with the fluorine at 673 Kelvin, 1 bar pressure, then form of xenon difluoride. Xenon difluoride. Next another one, xenon react with the 2 moles of the fluorine at 873 Kelvin and 1 bar pressure. That is the 1:5 ratio, then form of xenon tetrafluoride. Remaining another one, xenon reactor combining with the 3 moles of fluorine at 573 Kelvin and 62.7 bar pressure, then form of xenon tetrafluoride. Xenon tetrafluoride, that is the 3 binary compound of xenon difluoride, xenon tetrafluoride, xenon hexafluoride. Remaining last one, the xenon tetrafluoride react with the dioxide difluoride, then form of xenon hexafluoride. Hexa means that the 6 fluorine atom. And another one is the form of O2. That is the preparation of the xenon fluorides.